Okay, so right, so welcome to our HTML5 App Devs meetup. Thanks for coming, it's a great turnout. Hopefully you all like the Facebook space, it's new for us. Right, so just quick intro of what we do, why we're here. So like it all comes down to, my slide turner doesn't work. That's really what it's all about, man. We're gonna go to the space bar for now. I got it working. All right, so application developers, right? Why is this meetup group different? Because we're application developers. We're talking about developing serious apps, not say, fishbowl demos with how to use HTML5 Canvas. We're not going to teach you things like, oh, new API, this is cool. We're going to teach you how to build, crazy things like, say, meetup.com. This is a pretty serious HTML5 app they've built here with lots of functionality going on. What I think is really interesting is how HTML5 apps have taken off in a much broader direction than just traditional web apps. Back to Gmail. I work in my day job on a desktop application for Barnes & Noble that lets you read your ebooks. This is pretty neat. And of course, Microsoft has come out big in favor of these desktop apps in HTML5 with Windows 8 Metro apps. So I know for a fact that this is written in HTML5, this news app that comes bundled with Windows 8. And you can go look at the source code and see how crappy Microsoft's coding standards are. And speaking of HTML5 apps that have gotten some slack or some flack from the peanut gallery, there's our favorite Facebook app, which has a lot of criticism because it's HTML5 and a little bit slow. But if you think about it, this allowed them to take their website, which is a massive engineering undertaking, and put it in just a little code, from what I understand, and get a pretty impressive app that, yeah, it's a bit slow sometimes, but damn, I mean, that's cool. Right, so that's kind of my spiel. We're different, and we're excited about these technologies that we're going to be using, in our day jobs or in our free time. So that's why we're coming here, and that's why we're at a meetup talking about something as awesome and not at all nerdy as unit testing. So my presentation, which we're going to get started with, is called Unit Testing for Great Justice, because I really believe that unit testing is really cool, and hopefully that'll come through. So this is me. Got some links up here if you want to check me out. All my Node.js stuff I've written, all my stuff on GitHub, and also some of the stuff under our Noble.js, Barnes & Noble repository, because we've got some neat projects cooking there. Anyway, so I want to start off with a pretty simple question, which is, how do you know that your code actually works? And it's not actually that simple, of course. It's a trick question, because the answer is that it doesn't. Right? And this is true on multiple levels. If your code worked, you would have an empty bug tracker, and I don't know anybody with an empty bug tracker. So that's just, nobody's code actually works. But even if you had no bugs filed, if you miraculously said, no more feature development, we're going to crack down and fix all this, well, really, you don't know that all of your code is being hit by the users, right? You don't necessarily know that everything in your app has been necessarily exercised and works, right? So to know that something works, to really make sure that it works, you have to test it, and that's what this is about. But you don't want to test it manually. You don't want to be. We had QA engineers, and they're invaluable for certain things, but in the end, they tell us things like the server is down, and thus we can't download our ebooks. And that's really helpful, but not at all what we're interested in. Not to belittle, QA, but to point out that as developers, there's. I wish I'd included this comic in the chart, but there's a great graph of developers, how their productivity goes versus how most people's productivity goes. When you do things manually, eventually as a developer, you just get sick of it, you start automating it. And we have a computer. Why not make it test itself? So that's called automated testing, and there's two levels of automated testing. The first is kind of what you might think about, just integration testing. So this is telling the computer, using a tool like Selenium on the client side, I'm going to click this button, see what happens. It should pop up this dialog, and this user should be created. And you're going to enter stuff in a form, and it's actually going to go to your database and get stored there. And you get this test data in your database, and that's awesome. But whatever. And then you're going to go to another page and say, oh, hey, that user is on that profile, or whatever. Or for, I'm writing a Node.js server, what that means in this sense, what integration testing means there, is I'm going to actually spin up an instance of the server, point it to a testing database for niceness. And then, fire a bunch of HTTP requests against it and say, oh, I'm going to put this file there, and I'm going to pull this file there, and it should come back the same file, and that's good, right? And so that's very valuable, but in the end, the most valuable, I think, is unit testing, and we're going to talk about that in a lot of detail. But I did want to interject with this my favorite recent Twitter piece, which is from one of my favorite people on Twitter, Bob. So he says, when programmers are talk of safe sex, they are actual think of code with unit test, and the other way around. And of course, we had this wonderful follow-up from some random guy on Twitter who says, don't forget integration testing, and you can come up with your own analogy for what integration testing you should be thinking about. So I just want to throw that in there. Right, so unit testing, right? So what we want to talk about, and my talk is more on the theoretical, introductory side. I mean, there's certainly examples, it's certainly in JavaScript. But I really want to get across, why you should be doing unit testing and kind of how you should write good unit tests. We're going to let John Paul take it away with some more practical sides of how to make it work for you day to day. So let's start with what is a unit test, right? And so this really comes down to the question of what is a unit, okay? And so the answer to this is, does anybody know the answer? Okay. No, nobody knows what a unit is.
Thing under test. Anything?
The thing under test, anything. No, you are both wrong. A unit is a single function or method. Okay, I mean, this is actually a really helpful perspective to have because, yes, you do want to test like a unit in an abstract sense, but you also want to bring this down concretely to when you write a unit test, what should it be testing? Well, it should be testing a single function or method. Right, and so we can roll with this and go for a definition. Just go straight out and say a unit test is an automated piece of code that invokes a function and then checks assumptions about its logical behavior. And I've bolded some important words here, which we'll definitely dive into. So automated is pretty obvious, but the assumptions idea, that's the fact that we can make assumptions about our code. That's like a whole academic subject, correctness checking and preconditions and postconditions and so on. But it's really what unit testing is about. Is when this happens, what is my assumption that it does? And then logical behavior. This is something we'll be coming back to again and again. Because this is what you want to test, is the logic of your program. You don't want to test boring stuff like, a getter or a setter or something that just forwards logic to somewhere else. Like that's not actually what you want to test. That's not where the failure points to your program are. What you want to test is the logic, the stuff that actually makes your program tick. Okay, so let's get an example, just to make this more concrete. All right, so this is almost a real-world example from some of my code, where you take a excerpt from a book, and you get an array of highlights, okay, with like a start position, a length, and a color that you want to highlight it. You have to transform it into a string of HTML with that text highlighted, according to the algorithm. So I mean, it's pretty simple, right? You set up your excerpt and your highlights, and then you say, okay, well, I'm going to do the highlighting using this highlight function, and that's the unit that we're actually testing. And then I'm going to do the assertion about my assumptions. My assumption is that this correctly highlights that I expect the result to equal this HTML. And this pattern actually is something you really want to get in the habit of thinking about when you do unit tests. It's called arrange, act, assert. Okay, so you arrange your stuff, your system under test. You act to exercise the unit that you're actually testing, and then you assert about what the result should be. One other thing I want to touch on in the definition of unit test is how big should a unit be? And the answer, well, I mean, how big are your units, right? Like, how big are your functions, generally? Anybody want to tell me some numbers? 10 lines? So that's a pretty good number. Anybody want to tell me a more embarrassing number?
3,462 lines.
Yeah, I've worked with some of those functions. Those are definitely, I definitely had to work with some of those.
Charming.
Those are, charming. Charming is a great word for those functions. So how big should your units be, right? Especially if you want to test them. Well, yeah, it's about 10 lines. Good call. And of course, this isn't a hard and fast guideline, because what this is really about is that a unit-tested function should do one thing, and it should do it correctly, because you're testing that it does it correctly. If it did more than one thing, it would be much harder to test that you're doing it correctly. So really, 10 lines is of course just a guideline, but it's a pretty good one. I think you'll see as we get some examples. All right. So finally, what code should you unit test? Okay, and so the answer to this is quite simple. You should unit test all the code, just all of it, at least that has logic. Okay, so I mean, yes, there's getters and stuff in your code base that you don't need to test, but you should test all of your code because otherwise, how do you know it works, right? How do you know that you just wrote this code one day and it's like, oh, well, I'll just handle this error condition this way, but you never actually test that it handles that error condition correctly. You never know that it is correct. So that's really unfortunate, and we'll talk more about exactly why I believe that so strongly. So in conclusion, yeah, you should unit test all the things. All right, so why? Why should you unit test all the things, right? I've just told you effectively to write twice the code, right? You need to write these tests for everything that you do. Is it worth it? Well, I mean, I think the most compelling reasoning I've seen comes from this guy. His name is Uncle Bob. It's actually not his real name. His real name is Robert Martin, but that's his internet handle. And he is a big fan of unit tests and code and clean code and so on, software engineering best practices and so on. And he has this wonderful article that I just read again last night and fell in love all over again. And I felt like I needed to just channel it to you. Just channel Uncle Bob and read this to you. So get ready, all right? So he says software is a very sensitive domain. If a single bit of an 100 megabyte executable is wrong, the entire application can be brought to its knees. Very few other domains suffer such extreme sensitivity to error. But one very important domain does, accounting. A single-digit error in a massive pile of spreadsheets and financial statements can cost millions and bankrupt an organization. This is very true. You know, a single bit wrong, a single piece of line of code done incorrectly in your software can completely screw over an entire business or possibly people's lives these days. Right? So he goes on to explain that accountants have solved this problem long ago. They use a set of practices and disciplines that reduce the probability that errors can go undetected. One of these practices, and this is the key, is dual entry bookkeeping. Every transaction is entered twice, once in the credit books and once in the debit books. The two entries participate in very different calculations, but eventually result in a final result of 0. That 0 means that all the entries balance. A strong implication is that there are no single-digit errors. So this obviously isn't perfect, right? You know, people make errors with their financial books all the time, and people do lose millions of dollars. But the fact that they just go through so methodically and they apply two completely different practices to check each other is a strong indication, I think, of professionalism, right? And that's really what he's getting at. He says, we in software have a similar mechanism that provides the first line of defense, test-driven development, or more generally, unit tests. Every intention in our system is entered in two places, once in the unit test and once in the production code. These two entries follow very different pathways, but eventually sum to a green bar, right? A green bar that says, 500 out of 500 unit tests passed. That green bar means that the two intents balance, i.e. that the production code agrees with the tests. Okay, so I think this is really profound, because I was always told, you should write unit tests, it's good, you should make sure your system's tested. But I didn't really see a compelling reason just from this, it's just such a powerful analogy. If you want to be a professional software developer, you should be practicing this kind of professional way and saying, I'm going to check things using a standard engineering practice that ensures that all of my code actually does what I say it does, right? Nobody wants to deliver code that doesn't do what it says it does to their organization or to themselves, right? But the way to ensure that is by practice like this. And yeah, just like in accounting, this isn't foolproof. If you have bugs in both your test and your code, you're in trouble. You will have an actual production bug. But the chance of that is much less than the chance of bugs just in your production code. And what's great is if you have a bug in your test, your production code should catch that. So they really balance each other. All right, but this is actually kind of, if you think about it, just an argument for testing in general. So why should you unit test all the things? Well, okay, I'm going to give an example, right? This highlight function, and this is, notice it's pretty short because I've abstracted out everything into little pieces, right? This highlight function we looked at earlier has a few pieces of logic in it. It handles the link 0 case and it just does nothing. It looks for the case of overlapping highlights, right? So if you have red and yellow highlights right here, it's going to need to say, oh, well, I'm going to need to split those up into an orange highlight in the middle, and a red over here, and a yellow over here. And so it'll subdivide the highlights for that. It'll make some HTML tags, and it'll insert them into the excerpt before returning. So what's important here is, again, I've kept my unit very short. It's my function very short, 10 lines approximately. Right? And I've done that by pulling out other units. I've said, highlights overlap. That's a piece of logic. I'm going to put it in its own little unit. subdivide the highlights, make tags, insert tags. So my system, my highlight function, is actually composed of a lot of different pieces. So more generally, consider a system like this, where you get your input coming in, and depending on what that input looks like, it could go down a bunch of different paths. It could go ADE, it could go ACF, it could go BDE, whatever. Eventually it ends up in an output. And each step has its own complications, right, depending on the exact input. Let's say it could do 4 different things, which is kind of a reasonable thing for a 10-line function. It could have 4 different possible outputs, just roughly. All right, so let's say we were trying to test this all with an integration test. Just give it the input, look at the output. So that's 4 times 4 times 4 is 64 variations just for a single case, right, for ACE, because each of those little steps has complications. And so the total is 8 times 64, 512 tests to comprehensively cover your system. And those tests will really suck, right? They'll be hard to read. They'll differ from each other just in tiny little input variables and your tiny little outputs. And you'll be like, oh, this doesn't really give me any insight into my system at all. And they'll be very fragile, right? If you need to change some internal implementation detail of, say, C, or change actually the output of C, like how it behaves, you're going to have to change all the tests that depend on the C pathway. And that's going to be a real pain. And eventually you're going to stop maintaining your tests, and then all hell will break loose because you'll never know if your code is correct, and you should go cry. So unit test approach instead is that you test each of these individually. You test A individually, B, C, D, E, F. Right? And each test has 4 variations, giving 8 times 4 is 32 total tests instead of the 512 that we talked about before. And what's nice is each of these tests will clearly document the behavior of each piece. And it will be easy to change or add to them. So if you find a bug in the logic of B, you'll change your test for B, you'll verify that it works, and then you'll know that it fits in with the rest of your system because you just tested B in isolation. Finally, just some benefits that, more general and overall. You also get confidence that your code is correct, right? And this is actually really big because it gives you the ability to refactor without fear. Okay, so if you want to change how your code works without changing how it acts, right? So if you have the same inputs, should map to the same outputs, but you want to change the underlying logic to make it cleaner, prettier, a different abstraction, you can now do this because you just run your tests, and they passed before you did all that work. Now they're going to pass after you did all that work, so you know that your work is still good code. So that's really big. They also give you credibility. So if you're putting any code on the open source world, you really should have tests, otherwise people will just not use it. I mean, I don't trust any code without tests. That's really a recipe for disaster. And if you're handing code off to your coworkers, you want them to be able to say, oh, well, this guy's clearly documented and thought about his test cases. Somebody new is joining your team. You want to be able to say to them, no, we unit test our code. We employ good software engineering practices and know how things work. And finally, this is just a little thing I've discovered recently. You get some free documentation out of them. So, little examples here. This is a unit test output from a test runner for one of our functions in our code base at work, for our server, actually. And you don't have to read it, obviously, but the idea is it has this whole cascading series of choices and behaviors for how it should work. And you could say, and all those little green check marks are test cases that pass. But it's kind of cool because you can see exactly what the flow is for this server. And even more so, like I've done some links, and you can check them out afterwards when I upload the slides, where people have actually generated API documentation for each of their methods using the output of their unit tests. And it's really cool. It has like little test code inlines, so you know how should this method behave under this situation. You see it in code, as well as in an English description. But finally, the most important thing you get is testable code, right? And what does this mean? And how do I write testable code? So really what this comes down to, what writing testable code comes down to, is remembering that you should only test your code. You should not be testing Backbone. You should not be testing jQuery. You should not be testing the DOM. You should not be testing somebody else's server. You should not be testing the file system. You should be testing your code, okay? And so what that really means is that in the end, it's all about managing the dependencies of your code, right? It's about saying, well, I depend on jQuery, but that's not what I'm going to tie myself to. I'm going to be able to test my logic independent of jQuery's logic, for example. And we're definitely going to get into this, but I want to kind of give you some convincing on this, right? And I'm going to take a step back and look at the broader industry. This is actually why we use like MV whatever patterns, right? MVVM, MVC, MVP. This is because this situation, right? The model is all your code. It has no dependencies. The view has no logic. There's no need to test it. Now in Backbone, the view is actually kind of a controller or a presenter, so you might get confused with that. But typically the view is more your HTML. Okay, so it has no logic. It's just HTML. It's a template, whatever. Finally, the controller has simple logic and is easy to test using this concept called fakes. Okay, so if the logic is simple and it has dependencies that are clearly specified, you can fake out those dependencies. We're going to see how that works. But even more generally, like moving beyond just like the web and our favorite debates about MVV, whatever. This is why we use layered architecture, right? The idea that we have a domain model that only depends on itself, so you can test it in isolation. And then you have domain services that only depend on the domain models, so you can put in some fake models or some real models even. And then you can do application services that depend only on the domain layer, right? And you have infrastructure code, which translates your application and domain code into whatever the underlying mechanism is, whether it be AJAX or databases or whatever. But it's just going to be a straightforward translation. It's going to say, I'm going to store this object here. And you can test that kind of straightforward translation code super easily. And finally, the UI code, like your controller, just ties together like the application services and the views. And so if you inject some fake application services and some fake views, you can make sure it's doing the right thing extremely easily. All right, so let's dive into this. Let's dive into kind of each of these pieces and really see how this works, because this is the meat of the talk. So testing the domain model is easy, right? So this is an example from our app that worked with the ebooks, managing those. So the idea is like, we have a shelf object, and you can add books to it, and we want to test that this actually works. So we say new shelf, and we create a book. And notice that we're not actually creating a book object, we're just creating something with an ID. This is kind of a neat thing about JavaScript, is you can do stuff like this, because the only thing that matters is that that has an ID. Okay, so that's just a little aside. So we say we're going to arrange the situation by adding the book to the shelf. We're going to check out, does it have a book? Well, let's make sure that's true. Now this seems really trivial. A lot of people look at this kind of code if they've never seen unit testing before, and they're like, why are you writing this? Of course this is true. You added it, of course it has a book. Well, it's not actually that trivial, right? One day you're going to make a change to the logic of add book or of has book, and this just might fail. So it's really good to have this kind of test in place. And what's furthermore is this can guide you towards interfaces like has book and add book that are so simple and easy to work with because they need to be testable. We'll see more how that works later. Next I want to introduce, because we're still in the domain model and things are easy, I'll use this as an opportunity to introduce something a bit more advanced.
What are you testing there?
What am I testing? I'm testing the add book and the has book. So I'm really testing has book because that's what I'm acting. Okay, so I'm testing when I add a book, has book should return true.
So you just want one line in act, you want to put the add book in the act?
Very much so, yeah. I'm arranging the situation with the add book for self. So if I were to test add book, if that were going to be my act, I'd have to look at what add book actually does. So it might talk to a database, or it might store something for later talking to a database. So I test that code. Any other questions? Please feel free.
Well, I think I see what you're saying. If there's a bug in add book, has book is false. The assertion could fail because add book is not.
Right, it's true, it's true. I mean, there are pieces of it. When dealing with object-oriented programming, your methods are intertwined. It's not functional style where you can just test inputs, outputs.
Yeah, but you have a unit test for add book.
Exactly.
But could this also just be the add book test? Would it have to be different, or does this also
No, because this isn't the function. AddBook does something else. If all AddBook ever did was change how hasBook returned, then okay, I guess this could be the AddBook hasBook test. But AddBook probably also stores things in a local database and then synchronizes it later to the server.
Well, what you might want to indicate something like after add book, that shelf has one more book than it had before, or something like that.
Another good idea. Yeah, that's actually a really great point. I wish I said that 5 minutes ago when people started questioning it. Yeah, no, one thing you could do, as he said, is you could say I'm going to act by adding the book. I'm going to assert that shelf.books.length is one more than it used to be. So that's actually a really good point. Thank you. All right. So the next thing I wanted to introduce while we're still in the domain model and things are easy is the concept of spies, which is really important in JavaScript because we like our events. So the idea here is that I want to test that when you add a book to the shelf, it fires a book added event, okay? Because events aren't just something you use in the DOM, they're something you use to communicate among components in your application. And so the way you would do this is you create this spy, okay, using this library called sign-on, which, well, it's a function that records whether it's been called or not. And so you see this, you say, okay, well, arrange, I'm gonna create the spy, create the book, create the shelf, and then I'm gonna say, when you add a book, I will listen with this spy, using on. And then you're gonna act, you're gonna do the actual book addition, and then you're gonna assert that the spy was actually called with this book, right? You wanna say, okay, this event has been triggered with this argument. So, I mean, this makes sense, like, it's a little bit of technology and magic I'm introducing, this sign-on library with its spy concept. But it's a really natural thing when you think about it. You could write this test yourself without sign-on by creating a function that like sets a boolean to true and then checks if that boolean is true afterwards. But I want to just kind of put this out there because it really communicates your intent clearly. And by creating a spy, you know, something that says, you know, I'm going to go in there and spy on the result and see if it actually works. And also while we're here, I wanted to briefly introduce you to BDD, behavior-driven development. We'll be seeing more of that later. Now BDD has kind of two facets. Before we jump to the code, one of it is the idea that your business people are actually going to write your tests or specifications. So they're going to do things like write when a shelf is empty and you add a book, then it has one book. And then you're going to write some code to translate those strings into code, like unit test code, like assertions. And this is an interesting idea. I don't think many people actually do this. I don't know though, I work on a pretty small team. Maybe if you had like a bunch of technical product managers, they'd be really into this. But what it's actually come to mean, like more generally, or really more specifically to be honest, in the testing community is this style of writing tests, which is a bit different from the arrange, act, assert. So the idea here is that you can set up nested contexts. Wow, you can't see that because it's on the wrong screen. Right, cool. So the idea is you set up a nested context. You say, I'm going to describe the add book function. And then you do your setup that's common to all your tests for add book here in this like before each test block. Okay, so you say, I'm going to create a new shelf and a new book. And then you can just focus your tests purely on the act and the assert. Put the arrange up here, right? Or at least the arrange that is common to the whole situation, the add book situation. So you're going to say, and you're going to use descriptive names. This is another part of BDD. You're going to say something like, it should make hasbook respond correctly. And then you test that by doing the add book and expecting that hasbook is true. And you have another test with another descriptive name. It should trigger book added, right? And then you're going to do the same thing we did before. Create a spy, add the book, add the spy listener, so on, right? And so this is really just like a very simple style. Like I've taken those two slides we had previously where we duplicated the setup code, and I've transformed it into BDD style, where you have these nested contexts. And as you saw with my screenshot of the server, the nested context can go quite far, right? If you have common setup, like you can say, you know, when they're uploading a PDF, when they're uploading an EPUB, it should do all these different things and follow all this different flow, and have subtests and subtests. And we'll see some of those, you know, a little bit later. But I just wanted to gently introduce you to BDD because it's a style I really prefer. Right, that went seamlessly. All right, right. So now, okay, we're out of the domain. We don't get to work with simple domain models anymore, where it's nice and I can introduce you to concepts slowly. Let's talk about testing services, right? Because this is what we're all about here, is testing hard things that are harder to test and making our code easier to work with. So I want to test this downloader, and in particular I want to test its download method. So you call it with a book. So it has this behavior, this BDD style spec. When the app is offline, it should call back with a no internet error. When the app is online, and so on and so forth, it's talking to the DRM service, it's getting errors from that, it's going to do the download, it can get errors from that. So I'm testing all these different nested cases, and this is where BDD really shines in my opinion. But the point I wanted to make here is that we have a dependency. So let's take a stab at writing this first test. The when the app is offline should call back with a no internet error. Okay? Well, so we try to set it up. We're like, okay, new downloader, here's a fake book, you know, whatever. But how do we set up the app is offline? Well, we certainly can't just go around unplugging our network cable whenever we run our unit tests and then hopefully plugging it back in time for the next test. Like, that's a really bad idea. Automation, remember, we're smart programmers. And you know, so here's the rest of the test for the record. So the problem here is that our downloader, as it's written now, is untestable. And let me show you, like, oops. Yes, so this is our untestable downloader. Right, so we've written downloader to have a method called download that takes a book and a callback. And here's what it does as the first step. It uses the navigator online property. This is a new HTML5 thing. I told you guys HTML5 meetup. It checks and says, you know, well, if they're not online, then I better call back with that no internet error. But the problem is, like, navigator online is a state of our ambient environment. We can't do anything about that. It's read-only, like, for a good reason. You can't just suddenly put the user offline by setting that to false. That'd be really quite a security hole, I guess. So the way to fix this is with some magical, amazing thing called dependency injection. All right, so what you do is you say, I explicitly depend on the state of my environment. The idea that, you know, the user can be online or offline. So you inject it with an isOnline function in your downloader's constructor. Okay, and so this is a big win in a lot of ways. It makes our code more testable, as you'll see shortly, but also it explicitly calls out our dependency on the environment. Right, so how does this work, right? Well, our app code, instead of just new downloader, it becomes this. It becomes new downloader with this specific dependency, factoring out our online checker to say, oh, this is how you check if you're online. And the test code, of course, this is the whole point of this, becomes like this. We're testing the false case, so we just create a function that always returns false. Okay, well now we can test the false case without unplugging our network cable and go on about our business. So similarly, right, we do this for the rest of our dependencies because we want our code to be very testable and have our dependencies be very explicit. We have the downloader, we have dependency on the DRM service, we have a dependency on the download process itself using Ajax, and then we use those. So let's take a look at that code shortly. Okay, cool. We're on the right screen this time. All right, so it's very short again, right? Because we pulled out all our units into different pieces. So it's like, 10 lines of real code. So this is like before, but then we just check the DRM service, can download, you pass in the book ID. And then after that works, then you do the download, and then you pass that to callback. So we want to test this, right? So what do our tests look like? So I'm going to do some BDD style tests here. What you do is you set up your environment with these new piece of magic, new piece of sign-on technology called a stub. The stub is just like a fake method that you can make return whatever you want. And you could set up stubs yourself. But again, I think it really expresses the intent clearly when you use sign-on, as I'll show you. So you say, here's my stub is online, here's my stub DRM service with a stub can download, here's my stub Ajax downloader. I'm going to inject all those into my downloader during my tests. At the same time, I'll set up a little fake book because why not? Right, so here's our when the app is offline. We can set up the stub to return false in this case, and then do our test with the act, the act and the assert. And then we can do the same when the app is online. We change our stub to return true, right? And then we have a bunch of nested cases. We have when the DRM service says the user has run out of licenses. We say, well, the can download stub with the argument 123, which is the ID of our fake book, should return false. Now we have control over the DRM service, not just the internet state, right? And so then we can do the callback with no licenses left error, right? And so we tested that error should exist and have the right message. And then what about the case where it's true? Well, we just set the stub to return that. And we look at the download success case. Now we're stubbing out the do download Ajax function that we created, right? We say when you call it back with the correct arguments, so we're also testing the argument calling in this case, it should yield null and the book data, right? A little bit smaller, but yes. And then we do the download and we say, well, it shouldn't pass as an error, it should pass as the book data. But if the download fails with some underlying error, then we can call back and say, oh, well, it should have passed that underlying error back up through the callback chain. And as a little bonus, so this makes sense. Like everybody's seeing how this BDD nested thing works. We're getting a decent number of nods, a lot more than usually. This is awesome. You guys are cool. So finally, the app code, right? So this is how the app code works, and I think you get some interesting concepts here. So you saw the is online before. The DRM service is its own thing, right? You do that, and you're going to inject it with its own dependencies. Like it's going to need some computer data because it needs to check that this computer has permission to download this many books. It's going to need some configuration data to say like, oh, you can only download 5 books on alternate Tuesdays. And then we have the download Ajax function. So this is actually an example of infrastructure code, but it's very simple and very short. And as I said before, it's just doing some translation, right? It calls jQuery to do some Ajax, get the URL, and when it succeeds, it'll call back with the data. When it fails, it'll call back with a nice little error saying, there's a download error. It won't say like, status code 502. So you inject those. So the infrastructure code will need tests, right? You will need to test this, but it'll be really easy because it's just translating. And the details of how you say, okay, well, how do I translate jQuery into other things and test that that worked correctly, gets a little bit hairy. I think John Paul might talk about that. But the idea is that you can see how it'll be not very hard to test. So that's good, right? I told you I was testing services, but I'm actually testing, I'm showing you how to test the infrastructure as well.
What library are you using here?
Right, for the tests, these guys?
Yeah.
Yeah, Mocha, yeah. I'll give a slide with my favorite stuff at the end. But really, it's very similar to like Jasmine or many other BDD things these days. Finally, as a little bonus in this thing, you can look at it later. I wrote my tests in CoffeeScript. I think they're really short and pretty this way. I write all my tests in CoffeeScript, but that's a very personal choice, so I won't force that on you or talk about it for the rest of this talk. So, yeah. Right. So finally, let's just finish up. Oh.
So on the server side, where I encode a statically typed language,
Yes, okay, a statically typed language, I see.
So I would always call out my services explicitly. But with JavaScript, my habit has been to just assume that there is a browser if it is browser code, and there is jQuery if it's browser code, and then just to spy out my global dependencies like the navigator, which doesn't have the advantage of making explicit in the calling function that I'm going to depend on the navigator, but the tests are identical. And I'm curious to hear your opinion. Am I committing a grave sin, or is this the JavaScript way?
No, yeah, just to repeat, Scott's saying that in his tests, in his JavaScript tests, what he normally does is instead of injecting his dependencies, he overwrites them. Because JavaScript lets you do that in most cases. Well, and actually, most cases.
My external non-application dependencies, like the
Oh,
environment, like the download.
Okay, this is especially interesting actually, because I almost agree with that. So he's saying, okay, so for his dependencies, like the DRM service, he would inject those. But for things like his online or the download, he might directly call those and assume that jQuery is there, and then in his test, he would overwrite them with fake versions. And this is definitely one way to do it. I think it's a little bit less explicit, but this is the magic of JavaScript, is you can do that, and a lot of people do that. So I wouldn't really say you're doing it wrong.
It's a minor sin.
It's a minor sin against Dominic's testing style, not even against anybody
The
else.
sign-on stuff actually has the ability to do that globally.
Right.
There's a library that will help you with all that and restore automatically for you at the end.
Right.
Yeah, and so yeah, John Paul was saying sign-on can stub out all of Ajax and give you a fake server to test against. So you can just do normal code. In my testing religion, you should still make your infrastructure code very small and straightforward and transparent, so that when you do that test with your fake sign-on server, it's a very straightforward test. But it depends. All right. Finally, testing UI, right? It's much like testing services, right? You have to sub out all your dependencies, but now you have a really big dependency, one that we all deal with and love every day, which is the DOM, right? The document object model. So here's some UI code that I found on the internet. I guess, oh hey, my taskbar is in the way. That's awesome. Nope, it's still there. Well, anyway, there's a URL down there hidden below my taskbar where I found this. And we're so lost right Yes, right. So this is from the To-Do MVC app by Adi Osmani. And this is a backbone view, which is really a controller or a presenter, according to traditional thinking. What I'm showing here is the excerpt that I want to test and show you how to test, right? Which is that he hooks up the events. He says when you double click on this label, it should trigger the edit. And the edit function just has these two lines. It adds a class editing, and it focuses on this input. Right, so how would you test this, right? Well, let me show you how you should not test this first, because this is what you might think of when you're testing the DOM. You would do something like setting up your entire application, and then adding a to-do to that application, and then finding it as a DOM element, and then finding the label and double-clicking it. Because remember, that's what triggers an edit, is a double-click on the label. And then you'd say, okay, well, does it have the editing class? And has the document's active element changed to be the edit element? This is really bad in a lot of ways. Like, you have to set up your entire application to do this. So you're not testing a unit at all. And you're going to make your tests start depending on each other. Because you're probably not going to set up your entire application over and over in every test. You're going to set it up once, and then mutate your state as you go through the tests. And it's going to get really ugly. You won't be able to reorder your tests. You won't be able to run them independently. This is very fragile. It depends very much on the details of how I bound that event to the double click on the label. It depends on the state of the entire application in DOM. So the right way to do this is to test the unit, right? You're testing your to-do view, and in particular, you're testing the edit method. So you create a new to-do view, and you use the power of JavaScript to just overwrite properties of it. You say, I'm going to make the element just a random-ass jQuery element that I created. It's just a div, okay? And I'm going to make the input not even a real element. I'm going to make it something that has a focus method that's a spy, right? Because that's all we're testing, is this L gets its class added to it, and then we focus on the input. All right, and then we're going to act, we're going to call out the edit, and we're going to expect that the class got added to that random element that we created, not even one in the real DOM. And we're going to say that should be true. And we're going to say that the focus should have been called. So we've narrowed our test down to just those two lines by taking out those two little pieces. We're still dealing with the real DOM. We have to run this in a browser, unless you do some cool tricks on the server side, but it's out of the scope of this talk, unfortunately. So you're creating a random element, but it's in memory. It's not in the document. You're not setting up your entire application. You're focusing on that one edit method. All right, so to wrap up, in the last 5 minutes, it's a question of when should I write my tests? Okay, and so you probably know the answer, but I'm going to try and convince you why that's the right answer. So the approach I take on this is to talk about code coverage, right? So what does that mean? Right. Well, what that means is consider this highlight function from earlier. Okay. So we wrote a test for this earlier. We wrote a pretty simple test, and that test looks something like, in our favorite PDD style, when given a highlight and an excerpt, it should return the excerpt with the highlighting tags inserted. Like, that's a pretty cool test. It tested like the entire function, right? Right? That's what it was. Okay. Wrong. That is not what it tested. It did not test the entire function. Copy and paste here. Right? This is what it tested. And I've created this nice little things in the margin for you. It's got a check mark for all the lines that were tested, a little dotted circle for all the lines that were partially tested, right? Because we only tested one path of that condition. And it did not test either of these subcases. So we have not covered our function fully. And we do not know if these cases work. If there are overlapping highlights, everything could break. Undefined behavior. Your computer could come to life and kill you for all you know. Same thing for if there's no highlights. So how can you achieve 100% coverage? How can you, in other words, know that your code, all of it, actually works? Well, the trick is to use test-driven development, which is this really cool methodology that scares people off, but I think it's really not that bad, especially, So what does test-driven development mean? So there's 3 rules that you have to follow to be doing test-driven development. You're not allowed to write any production code unless it is to make a failing unit test pass, okay? So you're going to have to write your unit test first, is what this means, if you want to write any code. And then you're not allowed to write any more of a unit test than is sufficient to fail. So you're not going to write a bunch of unit tests all at once and then make your system work. That route lies a lot of pain and not much fun either. And you're not allowed to write any more production code than is sufficient to pass the one failing unit test. So you don't be like, oh, well, I made that unit test, and now I'm just going to write the rest of the function, right? So we'll see how this works, right? And we'll see how this gives you 100% code coverage. And it also makes development a lot more fun because you're constantly switching back and forth. If you write all your tests at once, you're gonna have a really boring day. But if you're like, oh, Monday I'll write all my tests, Tuesday I'll write code, you're gonna kill yourself on Monday. So the 3 steps of TDD are red, green, refactor. Okay, red meaning a failing test, green meaning a passing test. Refactor meaning let's change up the code. Now that we have a passing test, then we can be sure that any changes won't break it. Okay, so here's a more systematic approach to our highlighting function. Right? When there are no highlights, the excerpt should pass through unchanged. Okay? And so we get our red bar, 0 out of 1 test passed. All right, so let's say we write our code this way. This is an interesting approach, but actually it's wrong. Okay? So why is it wrong? It's wrong because it's wrong because we didn't follow the rule of TDD. We did not write just enough code to make this test pass. Remember? The test just had to pass. That's all we needed. And you can see this because we didn't achieve, well, you can see that as a symptom of this, we did not achieve 100% code coverage, right? This if condition, only part of it's been tested. In fact, our function will fail if the, I don't keep passing anything else, but yeah. So this is how much code you need to write to make that test pass, right? You're like, what? But my final code isn't going to look anything like this. That's okay. You're on a fast-paced TDD mission to get your green bar, okay? And so yes, you have 1 out of 1 test pass with only this amount of code, and most importantly, all of your code is covered, 100%, all those lines, all those nice green check marks. All right, let's move on, right? The next step, when there are simple, non-overlapping highlights, it should insert tags around those areas. Again, red bar, 1 out of 2 test pass, right? Well, now we expand the tag, now we expand the function. We say, okay, well now we're gonna do the other case. We're gonna make some tags and insert some tags and return them. And lo and behold, we've tested all these branches. Our first test tested this, our second test tested this. We're good to go. And you got your green bar back. Similarly, when there are overlapping highlights, it should subdivide them before inserting the tags. Well, that's not going to pass, right? We're going to put in a test case with some input data with overlapping highlights and say, oh, shoot, it really choked on that. It like tried to put invalid HTML with the tags overlapping. And you just subdivide it. And so you go and you write your test and you say if highlights overlap, then you're going to subdivide the highlights. You know, while you're doing this, you might have to go off and write some more tests for your highlights overlapping, your subdivide highlights function, and so on. But that's okay. They're independent units. You can go and do that. That's fine. So again, because we don't follow this approach, you know, we have a third test that tests this section of the code. So everything in here is being exercised. We have 3 out of 3 tests passed. But we forgot a step, right? What about the step where we get to refactor all the things? Or at least, you know, a small amount of the things, right? Well, what we're going to do is we're going to say, well, I didn't like that line, right, back there where we have this special case for 0 highlight. Probably, if you write the rest of your functions right, it should probably just work. It should just pass through and end up doing nothing, right? So let's try taking that out, and we do. And we run our tests and we see, oh, well, hey, we still have 100% code coverage, right? Because everything's still being exercised. And most importantly, 3 out of 3 of our tests are still passing. So if you apply these kind of TDD methodologies, then you can go and clean up your code later, keep your tests around, and make sure that all of your logic is still doing the right thing, even though you did this nice little cleanup and your function is just like 20% shorter. Love it. All right. So that's pretty much the end. In summary, yeah, you want to write unit tests, verify your application's logic, and then break it up into small units. And the reason you want to do that is because it's like double entry bookkeeping. It gives you the ability to refactor without fear and be a professional. Right? So writing unit tests will lead to writing testable code, which is decoupled via dependency injection, and thus becomes more modular, flexible, and comprehensible. And finally, the best way to write your unit tests, if you can really get into this, is with test-driven development, which has 3 steps: red, green, and refactor. And you want to make these steps as small as possible. You'll have more fun that way. Final slide, unit testing tools I like that you've seen in this presentation. So the Mocha test runner. You run your tests in this in the browser or on the server. The chai assertion library gives you that nice syntax like expect this to be true, expect this to be called with whatever. The sign-on spy style mock library, this is really invaluable for doing serious testing. I love it, and it has some really cool features that I think we'll hear more about shortly. If you're working on the server especially, or if you're doing a module system in the browser, use Sandbox Module Environment Faker, that's what I've called it. But it allows you to do things like set up fake global variables or fake module dependencies for when you haven't really done your code dependency injection style per se. Code coverage tool, this is called Cover. It's not very good, unfortunately. It requires a lot of fiddling to get to work. So I can't recommend it wholeheartedly, but it's working for me. I wish there was something that I could say, like, this is the best way to do code coverage, but I can't. And finally, some things I wrote, because I love unit testing. Chai, the assertion library, allows you to do plugins, so you can do specific types of assertions that look really nice. So sign-on Chai allows you to say things like expect this to be called with this, or expect this to return this. So you can do assertions about your spies and your stubs. And then Chai, as promised, if you remember back, if any of you were at the first talk this group did, I gave a talk on promises, which is a great way to do asynchronous coding. So you can do some pretty epic assertions with Chai as promised that end up making your test look super nice for asynchronous functions because they're using promises, and promises are super nice. Chai as promises is super nice. Okay. That's it. Yeah. Questions?
So yeah, I want to offer a slightly contrarian view, and hopefully I'll be able to leave the room safely afterwards. But I guess you'd agree that if you do a bang-up job on your unit tests, that you know that all the parts of your application work.
Yes.
You don't necessarily know that the application as a whole works. If you do a really bang-up job on, let's say, end-to-end testing, you have all these robust Selenium cases and so on, you know that what you've tested of your application works, but you still don't know that all the parts work, and so there could be some other case that someone could come up with that could break it. So my question is, if you just focused on a really bang-up job on the end-to-end tests, and you could prove that you had the coverage, what would you be missing over unit testing?
Right. So the question, if you didn't hear it, was, if you just focus on end-to-end integration style tests instead of unit tests, and you could prove that you had really good code coverage, that you covered, 100% or somewhere close to that every lines, what would you be missing out on? Well, I kind of tried to get at this. It's the idea of decoupling and unit tests making your code better. It's turning your code into something that is small, tiny units that are coupled in very clear and straightforward ways. So it's a lot of that. Also, there's the whole thing where, to get the same amount of coverage with integration tests as you do with unit tests, I had that little example with the system where, you're going to do 512 tests for integration, and you're going to do, was it 64 or 32 per unit? So you'll be missing out on a lot of your life because you'll be coding integration tests all day. Yeah.
Performance is another aspect.
Right.
My integration tests just take forever, but I can run thousands of unit tests in a fraction.
Yeah, especially in JavaScript, running unit tests is super fast. Like, you can run them when you save your files and stuff like that. I mean, we run them on every Git check-in. We run them all the time. So yeah, you can't really do that with integration tests. But integration tests I do want to put in work are super important. Like, I've had several situations in recent memory where I have written wonderful unit tests, and then I have booted up the server, and it's like, oh, I forgot to connect these two components at all. It doesn't work. No HTTP request service reaching the server.
Just to add, there's a spectrum between unit integration and Selenium. Like the Selenium is extremely end-to-end. There are integration tests that are just, say, the example like the highlighter and whatever is using the highlighter. You can make smaller integration tests if you want to.
Definitely.
Also, the provability of 100% test coverage or code coverage is probably not trivial.
It's not trivial to get the coverage.
To prove that you have covered 100% of your cases is probably a non-trivial thing.
Well, there's automated tools. I don't know. I don't know. I mean, in my experience, like, what they do is they add like a bunch of little function calls into every line and piece of your code. And if those get hit, then it says, oh, I covered this part of the code.
Crazy hack. It's called.
It is a crazy hack.
I feel like you can't prove that something converges or something like that. It's just a theoretical thing. So I guess my point was sort of what you were getting to before. I mean, you talked about things at a very granular level, and that kind of makes sense. And you have the integration or whatever at the highest level. But I can see that you have kind of a subsystem, and that's kind of like you want to be able to test something at a sort of a subsystem level as well. Because otherwise, you don't really know that all those little pieces are functioning together as a subsystem properly.
Right. Well, and so ideally, right, in the ideal, the code that fits your pieces together should have no logic in it. right? So if you remember, I gave those application code examples where I plugged that dependencies into my downloader, right? There was actually no logic there, right? I mean, there was the code that needed testing, like the infrastructure code, but the actual plugging them in, that was no logic. It was just declarative, here's my stuff, here's my dependencies. Now, it's useful to have some tests to say, like, did I not forget a parameter? But you can do very basic integration tests for that, like spin up the server and see is it responding, or spin up the web page and like, are there things on the screen? So in the ideal world, yeah, the integration tests are not as necessary, but very ideal.
I think you need them because you were talking about sort of the issue of state, you know, having things are small and then things that are, we have many tests, and I think that's really the issue is that you can't, unless you work at that level, you don't really know that you've tested all those different states.
Yes, right. No, I mean, that's fair. Definitely true. And as I said, I've been bitten by lack of integration tests, so I'm certainly not against them. I just want to tell you that unit tests are awesome and you should definitely do those.
Just following up on this gentleman's point about code coverage. If you've got various points in let's say, a function that's maybe slightly more than 10 lines, that, and you just want to see everything's been hit, but one can envision different pathways through that you may not have hit. In other words, you may have hit every individual line
Right.
in some pathway, but not in all the important pathways.
That's a good point. It's very true. Yeah, it is interesting. Like, code coverage is not a very perfect metric. It's a very reassuring one to have, but it certainly doesn't guarantee that you've tested everything your system can do. In the end, I mean, unit testing is somewhat inexact because you have to think up the test in the first place. And TDD tries to address that by saying you should never write code unless you have a test. So that's how you'll get tests that actually reflect all of the functionality of your system. But what if somebody passes an object that has crazy properties and does weird things to other objects living in the same memory space? I mean, you think that's not a problem in JavaScript, but like there's some DOM objects that do some crazy stuff.
Anyone without like build system can
So the question was, how do you automate your test for the build system?
yeah, you can start the whole.
I believe John Paul's going to talk about exactly that.
I was wondering if you run your tests for each targeted browser?
Okay, do I run my tests for each target browser? He's going to talk about that as well, I guess? All right, a little bit. I can't answer that question very well because I have been privileged to work in mono-browser environments. So,
Lucky guy.
yes, you should come work for Barnes & Noble and you too can be that lucky. All right. Anybody else? All right, cool. Well, let's take 5 minutes to refill your waters and so on, but let's definitely start out.